proofing means if in case tomorrow you have you are running the application on a newer platform or a newer processor system which has increased number of cores or which has increased number of processor itself in the system, the TBB ensures that it automatically adjusts to the new environment and ensures your application runs faster. So let us look at the components of TBB. In the components you see the parallel algorithms, it has the partitioners, it has the task groups, and it also has the scheduler. So these are some of the algorithms which are most used in the TBB, that is the parallel for, parallel reduce, parallel do. And what these particular APIs or particular templates do is, it breaks down your tasks into multiple small tasks and assigns these tasks into the corresponding thread. So once a particular thread finishes, it automatically assigns a next task to the same thread. So it will not keep waiting for the other threads to complete. So a real world example would be like, if you are constructing a house, the laborers who are working on your house are multi-talented, in the sense they can work on masonry, they can work on plumbing, they can work on electrification. So if you have 3 workers who are doing one task respectively, that is, one person is working on masonry, one person on plumbing, and one person on electricity, the moment electrical wiring or electrical work is complete, that person will start working on masonry, because masonry might take a long time. So he starts working on masonry to ensure that the whole construction process is speeded up. So as I told you, it's the task-based programming. So what are tasks? Tasks are the lightweight entities at the user levels. So the parallel algorithms of TBB maps these tasks onto the threads, as I mentioned. Then it is the work of the task scheduler to manage the thread pool. So the scheduler is unfair. So whichever, once a particular thread is complete, it automatically assigns the next thread or the next task which is present in the cache. So it will not ensure that anyone can hold a thread for a long time, or any task can hold a thread for a long time. Also, the scheduler, what it does is, it ensures the oversubscription and undersubscription of the core resources is prevented. So this is one of the examples for TBB. It is a parallel reduce function. So you can see the way the functions are written. The way, if it is a TBB function, you need to start the function name with a TBB and double colon. So automatically the compiler understands that it's a TBB function, and it loads it ensures that the threading TBB functions or the TBB templates are called. So there are 2 versions of TBB available. One is a open source version, and there is a commercial version. Open source version is free for download, and you can download it from threadingbuildingblocks.org. At the same time, if you want a commercial version, you can download that from the software.intel.com website. So the difference between the commercial version and the open version is, commercial version you get support from Intel itself, whereas in the open source it's a community driven project. So even there you get support, but not from Intel directly. So for Android purpose, to integrate TBB in your application, you need to make changes to your Android makefile, application makefile, and in your Java source. In your Java source, you need to load 2 more extra libraries, that is the GNU STL_shared library and the TBB library. In the application makefile, you need to set the app_stl flag to the shared flag, GNU STL shared flag. And there are other flags which you need to set in your android.make file. So it could be the module, it could be the source file, and the shared libraries. So you need to set these flags to include TBB in your application. So next, we will see a range of applications or a suite of products called the Intel Graphic Performance Analyzers. So this particular suite of product contains various other applications which helps you to fine-tune your graphics in your application.